Chapter 3, Section 3 is about rate of change and slope. These are things that we've been talking about already prior to this section, but we only discussed them very briefly. In Section 1, we went over how to graph a line, and we were using slope to help us do that, but we didn't really spend a ton of time going over what that meant as far as how do you find the slope. What are the differences that you might see in problems with slope, other than we just talked about you might see a positive or a negative. So I want to go into more detail about how to find slope and how you can actually use it to determine if the equation that you're dealing with is linear or not, and then see some examples of what these different types of slope might look like and how to find slope if you're not given an equation for the line and you need to be able to graph it. So something that you might hear us say is rate of change, which is another way of thinking about slope. And so it's just a ratio, so that would mean a fraction. That just kind of shows how one quantity changes compared to another quantity. And this would be the same idea as slope, where we talked about that rise over that run. Now, something to also be aware of with slope is that you're going to see this equation a lot in this section, where we're taking our y values on top and subtracting those over our x values, and we're subtracting. And like I said, this a lot of times we're going to refer to as rise over run. So between 2 points on a line, how much it goes up or down and how much it goes left or right in between those points is how we determine the rise over the run. So I want to get into some examples where they give you a chart and they want you to determine whether or not something is linear. Now, this first example is going to be one of a linear graph. So they might give you a chart, and these could also be viewed as coordinates. And one side on this one is giving you time in seconds, and the other side is giving you distance in feet. So the time in seconds, if I look at my numbers, it goes from 2 to 4, 4 to 6, 6 to 8. So all of these, as I go from one to the next, are increasing by adding 2. Now, if we look at the distance, they're also increasing, but over here we have a constant of adding 12 each time. Okay, so time is a constant of 2 seconds, because each of those is going up by 2. And distance is a constant of 12 feet, because each of those is increasing by 12 each time. So in order to find your unit rate of change, you would think of time as your x coordinates and distance as your y coordinates. And so you're always setting the y over the x. And so this would be putting the 12 over the 2, which would reduce down to 6. So what this means is that whatever this situation is, you're going 6 feet for every 1 second. Now, if you think about what that would look like on the graph, and I'm going to have to change my scale a little bit here because my numbers are getting quite big, so I'm not going to be able to fit all of my points on here. What I'm going to do for my x values is I'm going to have this go by 2s. And I'm going to have my y values go by 6s. So for that point 2, 12, I'm going to go over 2 and then up 6 and then 12. So there would be your first point. And then I'm going to keep doing that for those other ones. So over 2, 4, up 6, 12, 18, 24, and then you can keep graphing those other points. And you should see as I do that I'm getting this linear equation. So if I were to connect that, it still forms a straight line, but that line's slope or rate of change would be 6. So 6 over 1. So for every 6 feet, you're traveling 1 second of time. So that's an example of something that is linear. Now let's look at an example of something that isn't linear. So they're giving me a table once again, but if I look at my values, so for my x's I go from -2 to 1, 1 to 4, 4 to 7. All of these are still consistent in that we're adding 3. But my y's are not going to have that happen. Because if I look, 10 to 12 would be adding 2. 12 to 15 would be adding 3. 15 to 19 would be adding 4. So not consistent in the y's here, which means that these are not going to be linear because I can't set up like I did on that first one because it's not constant on both sides. It's only constant on the x. And if we look at the graph of this type of equation, and I'm going to change my scale on the y to going by 2's to be able to fit these points on there. Negative 2 is up at 2, 4, 6, 8, 10. 1 is at 12. Now those 2 points, that looks linear right now. But if I go to 4 and I go up to 15, so 2, 4, 6, 8, 10, 12, 14, 15, there's no way for me to connect these 3 points with one straight line. If I try to do that, it's not going to hit that third point. Even if I try to maybe do it this way by connecting those 2 points, they're still not going to hit that third one. So this is not linear. This one kind of has like a curved nature to it. So it's a curved line, which would no longer be linear. Because remember, linear lines have to be like stick straight. They can't have any curve to them. So what I want you guys to do is looking at these 2 charts down here, I want you to practice and decide whether the function that you see is linear or nonlinear. And if it is linear, I want you to find the rate of change. So for this first one, the x's, the 1, 2, 3, 4 for the days, that's all are going up by 1. And the money is all decreasing by 20, so it's going minus 20. So it is linear. And the constant would be negative 20 over 1, which is the same thing as just negative 20. Now over on the second example, the hours are increasing by 10 each time. And the money, though, it starts out looking like it's linear because it goes up 120, up 120, but then it goes up 160. So this one is non-linear, so you are not able to find the rate of change like we were able to on that first one. So if we go to the next page, this is going to continue to talk about slope, which is another way of thinking about rate of change. Now, rate of change, I would say, is used more when you're discussing problems that involve like a real life situation. So dealing with distance traveled over time or hours worked and money made, like something like that. Slope is more talked about when you're just looking at an equation of a line and you're just putting it on the coordinate plane. You're not maybe really understanding or you don't know maybe what the context of the problem is. So slope is the change in your y over your change in your x. And you can see again that that equation shows up that we saw earlier, where you take your y coordinates and you subtract those on top over your x coordinates. Now, there are a couple of different types of slope that we're going to see. So I want to go over some examples of slope with you. There's 4 major types of slope. The first type of slope would be considered positive. Okay? And so for each of these, I have an example underneath it of what a positive line would look like. So for example, on this first one, we've got 3x plus 2. Now I could graph that like usual up here. So remember what we did in section 1. We would start with the b, which is that 2. And so I would go up 2 and draw my first point. And then I would use my slope, which is 3 over a 1. So I would go up 3 and over 1. Or you could go down 3 and left 1. And then you would draw your line in. Okay? Now that would be a positive slope. Notice how as the line travels from the left side to the right side of the graph, it's going up. Okay, the second example would be a negative slope. So for this one, we started up at 8, but your slope was negative 4 over 1. So you go down 4 and to the right 1. And so if I connect those points, notice how that line goes down over time. So it looks different than the first one did. Now these next two types of slope are kind of a special case for both of them. If you notice on this one that's called zero slope, there is no x. It just says y equals 5. So what that would look like is you're going to go up to 5 on the y-axis, and it's going to be a straight line that goes through that point. So it's not going to have any movement like going positive or negative. It's going to be just a flat horizontal line, which means that it has no slope or zero slope. Now, undefined would be when you have an x value. So this one says x equals 7. So on the x-axis, you go over to 7. And if you draw your line through that point, that one's going to be straight up and down. So all lines that say y equals a number are going to be zero slope because they're going to be flat lines. And all equations that say x equals a number are going to be considered undefined because you can't find the rise over the run between those points on those types of lines. So what I want you guys to do on the example here is I want you to practice graphing x equals 3. So use the graphs I just gave you up above to help you do this one. So for this one, you are at x equals 3. So because you're just having an x value, you should be on the x-axis. You should go right 3. Kind of think about a point being there. And you should draw a line through the 3. Practice next is if you are given the graph of an equation and they want you to find the rate of change or find the slope of the graph or of the line. So to do this, what you're going to do is pick any 2 points that are on the line. And I would say pick easy points. So points that you for sure can read. Don't pick a point that's like in the middle of a square that you have to try to estimate where you think it's at. Find those points that land right on like the intersection of the squares on your graph. Then what you're going to do is count the distance on your y, and then you're going to count the distance on your x. And that means on the y-axis and on the x-axis. So how far to the left, to the right did you go? How far up, down did you go? And then remember, you're going to write it as a fraction with the y on top over the x. So y always goes on top and x always goes on the bottom. So for this first example here, for this example I gave you, I would maybe pick 2 points. Again, pick easy points. So I picked this one. That's at 1, 1. And another point that I picked is right here at 2, 3. And so to find my slope, I counted the distance on my y, so I looked to see, okay, from my first point up here, like how far up did I go? Well, I went up 1, 2, so that would be a positive 2. And then I looked to see how far over I went, which was just 1 to the right, so that's plus 1. So what they did is they took that 2, they put that on the top, and the 1, they put that on the bottom. And so they wrote it as that 2 over 1, or just 2. Now, sometimes when you do this, you'll get like 2 over maybe a 5. And then you're not going to be able to reduce it to just a 2. You're going to have to leave it as a fraction. So there's going to be times where your slope comes out to be a whole number. There's going to be times where it comes out to be a fraction, and that's okay. Now, another method that you can use to find rate of change is instead if they give you 2 points, we can use the slope formula. So the 2 points that I picked from that equation up above was 2, 3, and 4, 7. Now remember that your slope equation looks like this. y2 minus y1 over x2 minus x1. Now what I would do is just maybe look at those coordinates and label the first one x1, y1, and the second one x2, y2. And then you can kind of just plug them into the equation so that it kind of matches up and fits. So on the top, I put 7 minus 3, which is what they did here. And on the bottom, you've got 4 minus 2, which is here. Then they simplify by subtracting, so they got 4 over 2, which does reduce down to 2. So just like what we got up above, with counting, I got the same answer with using that equation. So I want you to practice using both of those methods. So pick 2 points on this line and use the first method where you count the distance between the 2 points. And then I want you to kind of confirm your answer by using that second method by actually plugging it into your slope equation and finding the slope. So again, when you do a problem like this, you're going to want to pick easy points. So I picked this point 1, 4, and then I also picked the point 4, 2. Just because those were going straight through those squares, those are easy for me to kind of estimate where they're at. Now the first method would be to count the distance between the points on the graph. So we went down 2, that would be a negative 2, and then we went right 3. So that would be a positive 3. So to use the first method, it would be negative 2 over 3. And again, you can't reduce that beyond that point. I can't take negative 2 and divide by 3, so I would have left it there. Now the second method, if you've got those 2 coordinates, 1, 4, and 4, 2, I'm going to call the first set x1, y1, and the second coordinate x2, y2. And then I plugged it into my slope equation, so 2 minus 4 over 4 minus 1. And I still get negative 2 over 3. So you can see how both of these answers came out to be the same, just using different methods. So going forward, if a problem specifies how they want you to find slope, then I would just use the method that they ask for. But if you can choose, I'm okay with you, if it's on a graph, using either of those methods. So you can either count the spaces between the points, or you can use the formula. Now you will want to be able to use the formula because you're going to be given examples like these next ones where they're giving you points and they're not giving you a graph that goes along with the points. So I can't use that first method where I just kind of count the spaces between the 2 points on my line. I actually have to use the equation here. So I'm just going to write that equation off to the side for me so that I can kind of just refer to it as needed. So remember that's y2 minus y1 over x2 minus x1. And if it's helpful for you to do what I was doing earlier, which is actually labeling your coordinates x1, y1, x2, y2, continue to do that. Which one you name x1, y1, or x2, y2, just pick whichever one you want to be it. And then I'm just going to plug this into my equation. So for my y2 minus y1 on top, that's going to be my 7 minus 4. And then on the bottom, I've got x2 minus x1, which would be 2 minus 2. Now, when I do this, 7 minus 4 is a 3, but 2 minus 2 is 0. If I take 3 divided by 0 on a calculator, you're going to get like an error message of some sort. You're not going to be able to take 3 and divide by 0. You can never divide by 0. It doesn't work. So if you ever come across this, you can't say 0 for an answer here, because that's not what would be the answer. What you would have to do is write undefined, because if you look at those coordinates, the x's were the same, so this is a line that goes straight up and down. It's a vertical line through that coordinate of 2, so it would have an undefined slope. Now, if you notice on this second example, we have 2 new coordinates given to us, and the y's are the same. They're both 7s. So again, if I label these x1, y1, and x2, y2, and then if I plug them into my equation, on the top I would have 7 minus 7. On the bottom, 3 minus 5. Well, 7 minus 7 is 0. 3 minus 5 is negative 2. But 0 divided by anything is going to be 0. So this would have a 0 slope. So this would be when it was like a y equals, and this one would be y equals 7. And so it's going to be a flat horizontal line. So I want you guys to practice this. I want you to take a look at these next 2 practice problems, find the slope of these 2, and write down what you think the answer should be. So for the first one, to set it up, I would have done 10 minus 10 over negative 4 minus 6. This should be 0 over negative 10, which simplifies down to 0. And for the second practice problem, I would have done negative 8 minus 5 over negative 2 minus negative 2. On the top there, you're going to get negative 13. On the bottom, if you do your keep change rule here, you end up canceling those out and you get a 0, which would be undefined. The thing I want to do is be able to use your slope to help you find a missing coordinate or a missing piece from the coordinate. So, for example, they might give you 2 points, like 2, 5, negative 3f, and then they're going to give you the slope, 3, 4, and they're going to want you to find that missing coordinate, so find what f should be. Now, in order to do this, we're going to use the slope formula, so we're still going to use that m equals y2 minus y1 over x2 minus x1. We're going to plug in the values that they give us, and then we're going to solve for that missing piece. So back up here, I'm going to call this one x1, y1, x2, y2, just to kind of help me be consistent with what I've been doing, and also allows me to see what I should be putting in for what here. So for this equation, in for m, you're going to put that 3/4. On top for your y's, I'm going to put f minus the 5. And on the bottom, I'm going to put negative 3 minus 2. Now what I can do is kind of simplify the bottom half of that fraction, that second one. So I've got 3 over 4 equals f minus 5 over negative 5. Now I need to solve for f here, so I got to somehow get this term alone. The first thing I want to do is get rid of the fraction over here on the right-hand side. So I need to get rid of that negative 5. To do that, I'm going to multiply both sides by a negative 5. Doing that is going to allow these two to cancel. And over here I'm going to multiply, so now I've got this negative 15 over 4 equals f minus 5. Now I need to get rid of the minus 5. Remember, the opposite of subtraction would be addition. So I'm going to add 5 over to both sides. So the negative 5 and 5 are going to cancel. We're going to have f equals, then you're going to want to add these two numbers, negative 15 over 4 plus 5. I would use a calculator maybe to help you with that, and you would get 5 over 4. So that would be your missing coordinate. So let's take a look at these last couple of problems here. We're going to do this next practice one together, and then I'll let you try to do one on your own. So again, I'm going to start by labeling this x1, y1, x2, y2. Plugging it into my slope equation, it's going to say negative 5 equals negative 4 minus 6. and then on the bottom f minus negative 2. So this would become negative 5 equals, on the top you're going to have a negative 10, and then the double negative there for the f minus minus 2, I would change that to f plus 2. Now for this one, the variable is in the denominator. I still want to get rid of this fraction. And so on that last problem, we multiplied by 5. Well, for this one, I need to actually multiply by that whole quantity of f plus 2. Now, when I do that over here on the right, those are going to cancel. That's how I get that negative 10. What you need to be careful of, though, on the left-hand side is that you distribute that negative 5. So it's going to say negative 5f minus 10. Then I would add 10 over. So you're going to have negative 5f equals a 0. I'm going to bring this up here. I would then divide by negative 5. 0 divided by anything is going to be 0. So f equals 0. So why don't you go ahead and try this last problem. So to get you started, I would have set it up like this. Then I would have simplified the bottom of that second fraction so that it says negative 14. I would multiply both sides by negative 14 to get that out of the denominator. So you would have 56 equals f minus 10. Then I would add 10. And I would have 66 equals